Hello again. Well, today I'm going to talk to you about SETI, the search for extraterrestrial intelligence, and why in actual fact it seems to have been deliberately crippled. So why am I saying it's crippled? After all, we know that they're devoting huge resources, massive radio telescopes and radio telescope arrays like this one, to scanning the heavens and looking for alien signals. Well, the main reason is because of the type of signals that they're likely to find, because interplanetary communications from one star system to another are extremely unlikely to use radio, and they're extremely unlikely to use laser. And the reason for this is the sheer time delay, the whole factor of how long it takes the signal to go from one place to another. So here's a short list of potentially habitable planets, and as you can see towards the right there you've got distance in light years, and the closest one is 13 light years away. Well, can you imagine having a conversation with someone when it takes 13 years for your message to get to them, 13 years for it to get back again, the reply to get back again? I mean, that's just mad. Let alone if it's one of the more distant ones and it takes over 1,000 years for your message to get to where it's going and 1,000 years to get back. That is not the way to tie together a galactic empire. And there's been lots of discussion about why it's all so quiet out there, why we can't detect signals, and the reason is that the only type of signal that we're likely to intercept is local signals between two spacecraft that are in the same sort of area, and these would be tight beam microwave signals. Now, why do I say that this is an issue? Well, it's an issue for a number of reasons, and one of them is the protocols that SETI actually set for themselves to be able to announce the detection of a signal. Now, you may have all heard of the WOW signal that was detected, where a signal that exactly matched the profile of one that could be used for communication in space was found, but it didn't last very long. There's a good reason for it not to last very long if it's a tight beam communication between ships, because the Earth's not in the same place. So the Earth would move away and out of the beam of the signal pretty damn rapidly, and not to mention the fact that the spaceship itself might be moving at a considerable fraction of the speed of light. So that cripples them, because let's face it, it's the needle in a haystack problem, because the needle happens to be pointing your way, a couple of seconds later it's not, and you will never ever pick up that signal on that frequency from that direction ever again. So how are these supposed interstellar neighbours of ours going to communicate? Well, if they've got faster than light travel, it's going to be an awful lot quicker to send a drone faster than light to wherever it is your message is being directed to, and just carry data in the form of a chip or written on a crystal or whatever. It might only be a tiny spacecraft, who knows, the size of a shoebox perhaps, but that is the way that they would do it. They certainly wouldn't do it by waiting over 1,000 years for a radio signal to arrive. So there is another thing, and that is the type of frequencies that SETI look for, and they look for frequencies which are in what is called the water hole, which is frequencies that are strongly absorbed by various interstellar media and retransmitted. There are places where The hydrogen molecule, for example, resonates strongly, so effectively the signal doesn't decay so much. And they regard this as being ideal for interstellar communications, but we know that these signals are not going to be used for interstellar communications because the distance is just too great. So all we can hope to get is ship to ship, and maybe ship to planet where the ship is close to its planet. So what should we be looking for? Well, the best thing to do is probably to look at the signals that we actually send out. I mean, after all, we've spent a lot of time thinking about ways to communicate with our far-flung spacecraft, and we do it quite frequently. So what do we use? Well, here's a page all about it. It's spaceacademy.net.au over in Australia, and it talks quite at length, and you can go and have a look yourself. I'm not going to go through it. It goes through all the basics about the radio spectrum and the different ranges. And here's the interesting bit, titled Windows to Space. Now, when we're communicating from the planet to a spacecraft, there's a lot of places that we cannot actually transmit, and the reason for that is that our ability to transmit and also to receive is conditioned by our atmosphere. Now, immediately people say, well, hang on a minute, all we need to do is have an orbital relay station and get the relay station to transmit, and we'll transmit to it on a different frequency, and then it can transmit on whatever the best frequency is for interstellar communication. Well, we don't do that. Why don't we do that? And the answer is power. It's very, very easy for us to transmit 5 megawatts or something like that in a tight beam from down here, but from up there, where all you've got really is a small amount of power available, transmitting at that sort of level, which is what is needed to go the extreme distances to even our Pioneer probes, is just out of the question. So we actually transmit in a different wavelength to the wavelengths that SETI are looking for. What SETI are looking for is quite low frequency. They're looking from 1.42 gigahertz to 1.66 gigahertz, and they've restricted themselves to this spectrum. So how do we communicate? Well, this goes on a bit further, and it does give you a nice little table about what different frequencies are used for, and we communicate with our spacecraft, our deep spacecraft, mainly in the S-band, which works quite well. And indeed, I believe that the Pioneer program, the S-band is actually what they use, and that's between 2 and 2.67 gigahertz, double the frequency that SETI is looking for. We then moved on to the X-band, which works a little bit better because you can get higher data transfer rates, and that's around about 8 to 9 gigahertz. And the most modern spacecraft will be using the Ka band, which is at 23 to 27 gigahertz. Now, SETI isn't looking for these at all. So logic would say if we communicate with our spacecraft using these frequencies because of the atmosphere, because these frequencies are the ones least absorbed by our atmosphere, then any civilization that's similar to us, that comes from an atmosphere with a similar constitution, with a similar amount of water vapor, would actually have to use these frequencies as well. So why on earth aren't we searching on these frequencies? Why haven't we found the Internet of Space yet? Well, there's a very simple answer to that, I think, and that is that those in a position to decide such things don't actually wish to find anything. Yes, they have to pay lip service to the idea of SETI and looking around to see if anyone's out there, but oh my god, just think of the situation if they found anything. So SETI is deliberately crippled. It's crippled by its rules in having to have a contact more than once, and we've just discussed that that is so unlikely. It would be like winning the lottery twice in a row. And they are also handicapped by the fact that the choice of frequencies that they are listening to are not the frequencies that any sane planetary civilization, including ourselves, uses to communicate with spacecraft within its own solar system. And as we've already discussed, they're not going to use radio for any other purpose unless they have two spacecraft that are in close enough distance to each other that the communication delay is maybe an hour or 2 hours. Then they might conceivably use a very tight beam microwave link. And because it's such a tight beam, it's almost inconceivable that that beam would just happen to hit our planet at a time when our big telescopes happen to be looking at that patch of sky. So in reality, SETI is crippled, and unless we change our rules, we improve our recording equipment, and we move to S-band, X-band or Ka band, preferably all three, our chances of detecting a communication via radio from another civilization is in fact very remote. Now, you might be wondering why I'm not suggesting things like medium wave and short wave and things like that. The answer is there are so many structures in space that already emit signals on those sort of wavelengths. Most planets do, stars certainly do, that our chances of being able to screen anything out from the noise, and here's some noise outside my window now, are very remote. And so we don't even bother looking on those bands. However, it might be worth looking on the AM band, because during the course of our early forays into radio, we actually transmitted 50 megawatts at one point of RF radiation on that band. And if anything, that will be what aliens will detect, because that globe is moving out at the speed of light, and it's getting towards the 85 light year mark as I speak. So SETI is really crippled. SETI is not actually going to find anything while it's crippled like this, and changes need to be made if it's to do so. On the other hand, if our attitude is, well, hey, we don't really want to know, then we should just carry on, stick our head in the sand, and not bothering to look for anything anywhere. Well, I hope you found this enjoyable and it's given you something to think about. If so, please like, share and subscribe. Thank you.
But classical, practical and factual. Arduinotronic, harmonic, ionic, bionic, atomic. It will astonish you. It's magical and casual, actual.